Hi, so my name is Premasim Jain and today we are going to learn about an important concept in Java which is called as exception handling. So before we start going into the actual nitty-gritty of the code technically, let's try to understand what do we mean by exceptions. So we all have some plan in life, which is, we plan something, but life is not that smooth that sometime it, or most of the time, it doesn't goes as per plan. So if there are some changes in plan, something which happens which is not accepted or expected and it happens, then how we can do the course correction? That's what this entire thing is all about. So let's have a scenario, a simple algorithm that we need to go and catch a flight. So we go and then we hire a rental car, and then there is a step that we need to take the car keys from the drop box, and then we need to take the car to our next destination in the airport. But for example, the car key doesn't come up from the box. Then what do we need to do? Our plan fails, our program fails, or so in those cases where we can expect that, hey, the car keys are not coming out from the box and we need to do our next step. So we have something to catch that scenario and course correct it so rest of the plan can be run successfully. So we can call up the call center guys and say, hey, we have a situation, and can you please send the duplicate keys through a drone or something you have, and then we can course correct. So same thing happens here in Java technically. So Java program is just like any other program. A real life situation can be simulated. So we have steps here. So once we think that we are on step 5, and then something can occur which can change the course of the program, which can prevent the rest of the statements following not to be executed, and which we don't want. So Java gives you a facility wherein whatever code which is risky, which can give you some issues, you can just wrap it around and try something on this, and let's see. You just need to try. If it works, it's good. If it fails, if it does not work, you can course correct in the catch block and there is a final statement. So after understanding the example, we'll just go to the technical points, and then we will do hands-on and we'll run code. We'll understand from that. So the exception handling in Java is one of the powerful mechanism to handle the runtime errors so that normal flow of the application can be maintained. In this page, we will learn about Java exception, its type, and the difference between checked and unchecked exceptions. What is exception? Dictionary meaning exception is an abnormal condition. In Java, exception is an event that disrupts the normal flow of a program. It is an object which is thrown at runtime. So everything in Java is technically an object, so is the exception. So this exception is thrown when something bad happens. Something abnormal, normal means a happy path, and abnormal means, for example, you're trying to print to a device, a printer, and unfortunately printer has some issues or it's turned off. So you're trying to send signal, but it's not getting sent. Then your next step was, once the printing is done, you are going to your program is going to ship it to the customer. But sometime if some condition happens, then you can just have a course correct. Hey, printer is not working, let's try fax. If fax is also not working, let's try emailing or something like that, which can be course corrected. So here exception handling is a mechanism to handle runtime errors such as class not found, IO exception, SQL exception, remote RMI exceptions. What I just gave you example of printer, that is IO exception. And SQL exception, so there are a lot of exception we'll see. Advantage of exception handling. The core advantage of exception handling is to maintain the normal flow of the application. Exception normally disrupts the normal flow of the application. That is why we use exception handling. Let's see the scenario. There are a lot of scenario. We'll just see them in the hands-on code. But before we move in there, let's go to the basics. So object class is the parent class of all other classes or all other objects. So the throwable is another class or interface, a class which extends object. And then you have exception object and error. So just remember, people may ask what's the difference between exception and error. So error is something which cannot be caught, or corrected, or course corrected, or anything like that. For example, your virtual machine has got some error and it got crashed. Then you cannot do anything because that's not in your hand. So there are things which are in your hand and you can do something with them. They would be called as exception. Everything else might come in the error. For example, you're trying to read from the disk and your disk is having some issues and it's getting crashed, then you cannot do anything. But in exception, you're expecting some number and then the number is null and you're getting a null pointer exception. You can always allow and change the value of the number from a null to a zero or a non-null to avoid these exceptions and catch them, correct them. Similar with arithmetic exception like divide by zero or infinity or number format exceptions. So now exceptions can be, thought of as two exceptions. One is called as checked exception and another is unchecked exception. So there are mainly two type of exception, and the checked exception, let's try to understand the difference. The class that extends throwable class, except runtime exception and error are known as checked exception. For example, IOSQL exception. Unchecked exception that extend runtime exception and known as unchecked exception. For example, null pointers, array index out of bounds, something like that. An error is irrecoverable, like out of memory error. So your machine is out of memory and it crashed, so you cannot recover it then and there. You might have to restart your process or your server. Let's try to understand a little bit deep on the checked and unchecked exception. So checked exception are something which you are certain that this is going to cause a problem, and then you have to have some way to do the course correction. And unchecked is it can happen, it might not happen. For example, you are going to buy something, some grocery, and the payment, you have to make the payment. And let's say if your credit card does not work, you have to catch it, because without payment you cannot take the stuff, otherwise it would be stealing. People can call the police. So these kind of situations in program wherein you have to have some way of course correcting the stuff which is happening, which might happen, which is going to throw the error for sure. You have to wrap it up in TryCatch block or throw or declare it. That those stuff are called as checked exception. Unchecked exception are something like it can happen, it might not happen, or they are not big deal. For example, you go to a store and you are asking for for a brand of water, but if that's not available, there is some other water. If water might come, might not, but you'll still have some or the other water. It's not that big a deal that you have to have, everything planned just to have some zips of some water. So you just to understand, it's very non-trivial stuff. So now we can map it. So null pointer can or cannot happen. If it happens, it's not big deal, it's easy, right? So it is called as unchecked exception. You don't have to put anything which can happen null pointer inside a try catch block. And the reason is anything can be null, and if they start putting everything to catch these exceptions, then all the code, more than the number of line of code, you will have the try catch blocks. However, the catched exceptions like the IO exception, which means in your program you're trying to talk to a printer or another device which is remote device, and there are chances that that device might not work, you might not be able to connect. So it might throw an exception that hey, I am not able to connect what you wanted or intended, so I am going to throw an exception, catch it, and have the alternative path or the exceptional path run to course correct it. So those stuff wherein you're sure you're going to get the exception, and it it impacts the entire flow in a very massive way, then you have to catch it or throw it or declare it. However, small exception. So these the first kind of the severe exceptions are called as checked exception. Java does not allow you even to compile, get your code compiled if you don't catch it or put it in try catch block or declare it. However, these unchecked exception, you don't need to, but if you still want, you can catch them. That's not a big deal. So common scenarios. So now let's try a program here. Uh, let's try a program. Give me a moment. My idea just got crashed. Okay, so till the time idea comes up, let's see the code. So here scenario where arithmetic exception occur. So if anything gets divided by 0, it's not acceptable, and computer go nuts basically. It doesn't know what to do, and then it throws an exception which is arithmetic exception. This is an unchecked exception. So wherever you divide u, it's your responsibility to see that you're not dividing it by 0, and if you are, then you might catch it or might not. It's a programmatic thing, just leave it. Same thing with null. You just need to make sure that whatever object you're calling dot operator or the methods, it shouldn't be null. So you have to initialize it properly before calling any method on it. If you happen to have the null, you might get null pointer exception, and you can catch it, no big deal. That's called a unchecked exception. You're trying to parse a string, but unfortunately whatever you're parsing, it's not a number, it's alphabet. Then you be ready to get this exception. It might or might not happen. Same with array list. So programmer has to know that how many, what's the limit, what's the size, and he should not try to programmatically get the element which is more than the size. So if it's a good program, he before calling these stuff, he can just check it. A check means he can just say, hey, if this is less than the size of this, execute the line of code. So these exception can be avoided. That's why this is called as unchecked exception. Now there are 5 keywords, which is try, catch, finally, throw, and throws. So catch, now let's go to the program and we'll just walk through. So this is just a normal program. We are going to run it. Imagine it doesn't have any try catch, nothing. So what is happening over here? You have a balance which is 0. For example, you have couple of $1,000 in your account and you're trying to run it. So it's gonna run. Here is your rest of the code. Here is your program. Now what happens is, if in case that this unchecked, so if you're writing this code, program does not force you to have try catch, but in case if you're expecting and you wanna course correct it, so what we are doing here, that if exception happens in this code, we can do the correction and can assign a default value to this variable. Let's go and run it. So now exception doesn't occur. Actually, exception occurred. The class, the JVM inside it, it threw an exception on this line, but then we caught it over here on the catch. Once we caught the exception, then here is the line, and then here is what we printed, whatever data assignment we were supposed to do, and that's how the rest of the code worked. Otherwise, if we might have not corrected it, so the program might have failed and this line will not execute. We'll just see it again. I haven't saved it, sorry. And then let's see. So we have to get the condition where it throws the exception. Yep. So this line it does not got executed because this the flow it went to the sad path or the exceptional path and exited the entire flow of the program. So that's why wherever, and same thing you can do with nulls as well. So if you are going to do a data dot, any method is fine, even you can do toString. Now you are gonna get one null pointer exception, and this code will not even go here. And as expected, you got null pointer exception on line number 11. Now how to correct this? You can put this code here, and then you can put it here. This might not get corrected. Let's see what happens here. So you're trying to say the program that if arithmetic exception happens, I gonna catch it. But if null pointer exception, you're not telling anything to the program. So it might end up with the same problematic stuff because the exception happened here and you haven't caught it. So whatever the code you have, you might have to catch its respective probable exception. So you can say that whenever the null pointer exception happens, you can do, you can probably log the error, and then whatever is your data, it was null, so you can say it, okay, it's not null, it has got some default value. And remember, these are block scopes, these are the blocks. So whatever value you are putting up here is, it's going to so it's just a method scope, the value remains inside the bracket. If you're having, so I'll just give you another example. If you define something here and then it's a block scope, and then if you try and would like to use it in another block, you might not, because this is not visible outside its own brackets. However, if you gonna do it here, then this won't mind, it would print it. So let's try. What we did here is we had a value which was null, and our code was trying to print a call a method on null. We might expect a null pointer exception, which we are going to catch it, and then the normal flow would run. So the normal flow ran, and you are able to print that Java. So here you just printed whatever was the message on because the data was null, and then you assigned a value. Now please remember that as soon as the code gets exception, until the time, first thing it would do, it would go to the catch, respective catch, and intermediate steps might get skipped. And once that exception is corrected, then the normal flow will resume. So you just need to make sure that either you put this code in two different try catches, because if you are going to put it in one, first exception will eat another condition. It will not run the another condition. So that's a little bit tricky and to be understood. If you will change the number, first the arithmetic exception will happen and then the null pointer. So as soon as the code goes here, then it would go here, and that's how it would run. So we are trying to run this in debug mode so that we can actually see it, but seems like my IntelliJ does not like it. So we'll just give it some time and we'll move ahead to understand the concepts. So what is finally, so we understood the try bracket will wrap whatever is the risky condition which can give you trouble, and whenever you are getting a trouble from the code, you are going to catch it. After catching it, you're going to correct it. After you take the corrective measures, the normal flow would resume. However, if you have to run some code which has to run in both the cases, if the exception occurs or does not occur, then the finally block would come. So here it's back again. I have got a debug point here. So this is called as debugging. Now the control flow stopped over here because it got this point. It went here first. Balance was 0. It got exception. Exception was caught. Name of the exception is arithmetic exception. Divide by 0. We are printing it and then going ahead. So your data was null. Here was the value. Once you go to next step, you will see another value which would the assignment would happen after this line. So wherever the control you see, this line hasn't been executed, but it is about to execute. Right now the value is null. So you go down. Now the value is 1, whatever you assigned it. So assignment happened and this block never ran because this was not this kind of exception. So we would expect this line to run. So let's try this, this. The rest of the code ran successfully. Program terminated from this and this address. That's how it happened. Now we were talking about finally. So what happens with finally block? This is gonna run always. So exception might occur or might not occur, but this is going to run always. So when do we do this is, let's say I'm trying to open a remote connection and then I'm trying to write something on the connection, and then if something happens to the connection that it is not able to write the expected value, I'm going to write it with the default value in the this catch block. But no matter, the connection can go fine here, so it cannot come in catch block, or the connection had some issues for writing and then I do it in the catch block. Both ways I need to close the file which I have opened. So that's how that kind of code is written in the finally block. So we'll say close the file, close the file. Here you are trying to write to a file. No, yeah, write to a file. And for example, let's say, let's come here, right. So you was trying to write some value to a file, and somehow if that doesn't work, you are trying to write some default value to a file. So let's try and remove this. So it's super simple. You are trying to divide a data, you're trying to assign a number after division to this, and then you're trying to write. But if write doesn't happen, then you're trying to write it in the file. If write happens or write doesn't happens, no matter what, but you have to close the file. So let's try to run this. So in condition, it would write here, write to a file, then it had some issues. It would go to this block, it would assign the default value, then it is supposed to come to the finally block. Whatever code is there in the finally block, it's going to run there, and then it's going to move ahead. That's how this exceptional flow works. And we are back. See, so exception occurred. We go to console. This is called as console, and console will print whatever. If you don't give any terminal ID or log file path, it is going to take it as the standard output, and it's going to uh, stream whatever bytes it gets created. It's going to write on the console by default. So let's go finally. See, so this is the case where the exception occurred and finally block is gonna get returned, and it has returned it, and then it came out. Now let's try to make it a condition where it's a happy path and see if it finally works. So we are gonna run it normally, otherwise it's gonna get forever. See, everything worked fine. It was a happy path. So TryCatch, we already understood. TryCatch is a pair. You cannot just do a try without a catch. So you might do a try and finally a try or catch. Java catch block. So catch block, whatever the problem happens, you are trying to handle that problem in the code. You're trying to problem solution, whatever is the solution for that code inside the this block. And this is how the internal working of TryCatch. So you did something, exception object was thrown, was it handled? You put it in the catch, was it handled? If it is handled, it would run the rest of the code. If it is not handled, it is going to send interrupt to the JVM, and then JVM is going to print the stack trace and terminate it. So by default, JVM also handles this exception, but it won't print the rest of the code. And the way it handles is it doesn't know what you wanna tackle that condition with. So it's gonna just throw the exception onto the console. It would provide some description which will give you a sense that what really happened, and then it's gonna terminate the program. JVM first checks whether the exception is handled or not. If exception is not handled, JVM provides a default exception handler that performs the following task, and these are the tasks. So you can have multiple try-catch blocks in your code. You would have first try, and even inside the catch you can have a try-catch, or even inside a try you can have a try block. So there are several permutation and combination. This would be you guys can just reach out here and you can try different stuff over there. So I am going to just run one simple sample program here. So let me just push the code till here so that we can make modifications. So git add. This code would be available in our GitHub repository. You can just pull it and try it out. So I'm going to paste the link of the Git repository as well. I just merge a pull request, so that's why it's not in sync and it's asking to do a pull. So we can do git pull origin master. Now we're gonna do git push origin master. Okay, we are cool. So now we're gonna do a nested TryCatch. So what it means is you have a TryCatch now and then you have another piece of code which might be risky. So you can have another, for example, you are trying to do a data.toString here, and then it can throw the null pointer exception. So I'm just trying to reshuffle this a little bit up to show you guys how nested try-catch works. And this is perfectly fine. Java is cool with it. So what is happening is first you're trying to see if it's not an arithmetic exception. If it's not an arithmetic exception, then you're trying to see if it's not a null pointer exception. In case anything happens, you handle it then and there. So we'll try to shoot for this exception to occur. So we'll say data equal to null. So what is happening here for this line of code, the exception might not occur here, but once you make it null, so in program it can happen anyways, but we are just trying to simulate it. So this program, if this program throws any exception, it would be caught here, arithmetic exception. If this line doesn't give you any trouble and the next line is going to give you trouble, which is in another block, it would get handled over here. Let's try to run. And this would be fun if you would try several things on your box. So rest of the code ran finally, the finally block ran properly. There was a null pointer exception which was inside another try, and everything worked fine. So now we're gonna comment it and let's see. So no exception will occur in this case. So this is just a super smooth happy path. Now let's try and simulate a arithmetic exception. In that case, this will not have a trouble.
Sir, will you unmute yourself?
So, Bragdish, what we can do is you might have to join from the phone number.
Sir, I think you mute yourself.
So now we are going to run about the Java finally block, how it works. So Java finally block, we already know that whenever you're trying to execute the program, first condition is, so everything in a programming is a statement which will give you a true or a false, a conditional statement basically. So if it's a true, if it's a yes, or if it's a no. So if exception occurred, it's a no, then you go to finally block. If it happened yes, then you can handle exception here again, and then you can go to finally block. It's going to execute no matter whatever is usage of finally block. So we already understood that you're trying to open a file, and no matter you're able to write on it, you have to close that file, that byte stream or that remote connectivity. So that's how it happens in TryCatch finally scenario. Now we're gonna see next. So this is something which is called as throw exception, wherein you are trying to throw your own exception. So here you can create an object of IO exception. I would also like to tell you that the parent class is exception. So there is something which is called as diaper padding, which means that instead of writing the nested blocks, let me roll back the code. Just a moment. I'll just push this with the name nested so you guys can try it out later. So now what we're gonna do here is we are going to understand a concept which is called as diaper padding. Diaper padding means if you do like this and it's fine, you don't need this, and then so you're trying to do some code which could give you any kind of exception. Let's say the null pointer exception or arithmetic exception or IO exception. So even if you just do exception, exception is parent class, and all other exception are basically, the subclasses for this. So if you define it in the parent, it is going to go ahead and correct the execution path of the program. So we are trying to run it. So arithmetic exception happened here. It got caught by this You haven't asked this guy that, hey, this is the arithmetic exception. No, no big deal. If you will correct this condition, now you might have the null pointer exception, and the same block caught it. Then why don't we always use this exception, the parent class? What's the need to have, so many catches and then put it here and this and that? So the use case for this is, so use case for this when you need to, this is called as diaper padding, which means whatever exception comes in whatever line of code, by doing this, your parent class exception, you're trying to grab everything, and then you don't get the opportunity to correct it. But if you are trying to just focus on whatever exception it's gonna be, you can take the corrective measures based on that. For example, first thing, whenever you're trying to access, and by the way, you cannot catch it in a duplicate block. It has to be something different. So first thing, there could be a null pointer, and whenever there is a null pointer, you can assign it some value, whatever value you want. It could be if it's a string or whatever. Second, if you feel that it could be some IO exception, or if it could be some arithmetic exception, you can use that here. And then, for example, you are not expecting some exception and it can happen, which even you don't know, then you don't have to catch it. You can just do a catch-all, which is called as this exception. So a good programmer is going to write specific exception and take the corrective measures on the catch block. So we'll say if arithmetic exception happens, do some math magic to correct it. If null pointer exception happens here, assign some not null value to correct it. So that's how the specific. Now if you would try to do the other way around, first you would try to catch the more generic exception, then the specific exception. I believe that you will end up with compilation error. Java doesn't like it because there is a sequence. So you can think of as different size of balls. So this is going to be a small net. So small ball would be caught here. A bit bigger would be caught here. And the biggest ball is going to catch in this. But if you are trying to make it other way around, then whatever ball comes, everything will come here. Then these nets are not of any use. So you are not going to catch anything here. That's why Java doesn't allow you even to get it compiled. So here what is happening is you've written a code and it is going to go through some catches, and then it's going to execute the finally block, and then the rest of the program will resume. These stuff might or might not get called, but finally is always going to get called unless there is some error which happens, something like system.exit. So this is the only time when system crashes or exists programmatically or by virtue of some mm, JVM issues, then it's going to get terminated. Now you don't see the close the file stuff because the program got exited here. And we are just trying to simulate to learn it better. Now everything is cool, everything seems good. So it's going to complete the finally block, and then it's going to run the normal path, which is our rest of the code of the program. Now throw means you can throw your own exception. So we are going to try this. What we are going to do here is, let me make custom exception class, because if I will going to override and commit it, there are two ways. Either you can check out that commit to see the code, but the better way is you should have it in a separate class, which is called as custom exception. So imagine you're working for DMV or DPS. In California, they call it as DMV, driving motor vehicle something. So a person who is less than 15 should not be allowed to drive a car. In case, so you are writing a program which is, around the licensing and everything like that, and the basic criteria happens, then you should raise the exception then and there, and should not allow the exception to get propagated. So that's what we are trying to do here. Let's try to run this first. So our age is 18. If age whatever is less than 18, let's make it, I believe it's 16. It's different for different states, but let's make whatever you're trying to print, your validate function is gonna call, and if the age, if this condition doesn't meet, it's going to give an system exception which you are trying to throw all by yourself programmatically. So JVM, if this value could have been divided by 0 or something, this stuff might have been done by the JVM itself. But now you have the capability that you can also do it by yourself. Now, why to call it as arithmetic exception? Because it has some different stuff. You can make your own exception. So you can say underage exception, and then you can throw that. So let's try something cool. We'll say underage exception, and then it can extend exception. So this is your underage exception. You can have some method or some that doesn't matter, and then you can throw this exception, and your exception does not take any message. So let's try to have a public constructor which would take some message, and there you go. Now it is saying unhandled exception. So this exception needs to be handled. So what we are going to do here is we will have a try and a catch block, and we are going to catch our own custom exception, and then we are going to print our own exception. So this is something like this. Let's try to run and see if our this guy works. And it worked. Where is this W coming from? Okay, here, my bad. And whenever it's getting created inside the constructor, you can have something here saying exception creation life cycle event. So the exception creation happened. You threw the exception. Once the exception is thrown, you caught it, you made the course correction. So this course correction would be you display a message, and then you can, if it's a UI, you can return and give the message to the user. Hey, you're underage, please come after 3 years when you're adult or you're more than 15. Now, this is what is called as the stack, call stack. So what we are going to do is we are going to continue this session tomorrow, and we'll also have the session on Thursday, and we are going to continue on this, how this stack trace works when one method calls another, and how you can get rid of the mm, uh, basically when you're not trying to handle a situation all by yourself and you want the program to handle it, or you want the caller of your method to handle it. So all those situations we are going to understand hands-on on this for, and then we will also see something on nested classes, and that's all. That's what it is for tomorrow. And your homework would be to try out these exceptions and nested exceptions and raise the pull request.